Kirkleman. Hello and welcome back to Module 10. We are here looking at day 2 where we're going to look at the properties of operations. So in this lesson, we are going to work on identifying a property of operation and then use them to make equivalent expressions, okay? So properties are kind of like just little rules that we know about in math, things that we know to be true, and we can prove them to be true, and therefore I can use these properties to kind of do things to expressions, expressions like this where they're all just letters. Even though I don't know what these letters mean, I know that what I did still made it equivalent because of this property, okay? Because I know it's true with numbers as well. So what we're going to do is look at these commutative properties, and then we're going to prove that they are true, and give examples on what they're not, and things like that. So the first one is the commutative property. Now, I remember the commutative property because of a word commute, which means to move from place to place. It's not probably the full proper definition, but that's how I remember that the commutative property has to do with moving and moving things around and changing the order. The word commute is in the word commutative property, so that's how I remember it. But the word commute we use to say things like on my commute to work, which is like on my drive to work. Oh man, there's a lot of traffic on my commute to work. Oh man, this commute's gonna take me 3 hours. Things like that. So that's kind of how I remember it, but the commutative property allows you to change the order of the numbers without changing the solution. Commutative property only applies to addition and multiplication. I cannot use it with any other operation. So we're going to prove it, right? So here we have an expression, p plus r plus s, and we're saying that it's the same as r plus p plus s. Well, let's prove it. Okay, so down here, they're giving us letters. They're saying, well, what if p is 12 and r is 5 and s is 2? So we're going to just replace those letters to prove that p plus r plus s is the same as r plus p plus s. So if instead we're going to say, okay, p is 12, r is 5, and s is 2. And we're saying that's the same as r is 5, p is 12, and s is 2. Well, 12 plus 5 is 17 plus 2. 5 plus 12 is 17 plus 2, so that's 19 on both sides, which is true. Okay? Now in multiplication, we can prove it as well. P times R versus R times P. Remember, that dot is the same thing as a multiplication sign, right? These mean multiply. Okay? And also, if we have parentheses too, that also can mean multiply when you have like something, right? So here, A times B is the same as A times B. That's why we don't use the times symbol though, because it looks like an X, which is the same as A times B, which is the same as A times B. All of that is multiplication. Okay, back to proving here. Okay, so we still have our same numbers, 12 for P and 5 for R. So 12 times 5 is the same as 5 times 12. And you should know that that is true. Doesn't matter which way we multiply, and it doesn't matter which order we add. So we know that it is not true, since it's true for addition and multiplication, it is not true for subtraction and division. Now, we have to give an example, because when you're learning something new, you need examples and non-examples, right? When you were little and you were learning what a dog was, any four-legged creature was a dog. You would see a cow and say, is that a dog? And your parents would say, no, that's a cow. And so it wasn't until you learned what a dog is not that you fully understood what a dog is. And so that's the same thing here, is we know addition and multiplication work, but we have to prove why subtraction would not work so that we fully understand the commutative property. So you're going to think of an example. Why would subtraction not work? Well, let's just use some of my same numbers here. 12 minus 5 minus 2 is not the same as 5 minus 12 minus 2. Okay, whoops. And we know that those are not the same because 12 take away 5 is going to give me 7, and 7 take away 2 is not the same as 5 take away 12, which is negative 7 take away 2. Now we're in the negatives, and you're going to end up getting 5 and negative 9. And those two things are not the same. Okay, the associative property is a property I remember from the word associate. Hopefully you know that the word associate means who you group with, who you're friends with, who you associate with. Okay, I associate with these people. They are my friends. So associative property has to do with grouping different sets of numbers together. And it says that I can group different sets of numbers together and I won't change the solution. And it only applies, again, to addition and multiplication. Okay, so again, we're going to prove it. So we're going to replace these numbers once more with, or these letters with the numbers they represent. They're using the same values. So we know that P is 12, and R is 5, and S is 2. 12, 5, and 2. And then we're just looking at these parentheses. So if I do order of operations, 12 plus 5 gives me 17 plus 2, and 12 plus 5 plus 2 is 7. And again, I'm going to get 19 equals 19. And that is true. So it doesn't matter how I group it. My addition problem is the same. Now on this side, it's going to be the same thing. 12 times 5 times 2 versus 12 times the quantity 5 times 2. 12 times 5 is 60 times 2. And then 12 times 5 times 2 is 10. Well, this is 120. And this is 120. So again, they are the same. And also, again, we know that it does not work for subtraction or division. So we need to give an example why division is not associative. So let's group division. So let's do 12 divided by 2, and then that divided by 3. Change the numbers a little bit. Versus 12, I'm going to put a division sign there, divided by the quantity 2 divided by 3. Okay, so 12 divided by 2 is 6. 6 divided by 3 is 2. 12 divided by 2 divided by 3 is 2/3, or 6 repeating, 6/10 repeating. And then if I do 12, or I can do fraction and do 12 divided by 2/3, which is 12 times 3 over 2, which is going to give me, cross cancel, 18. So this would be 18. Well, 2 and 18 are not the same, so these do not equal each other. All right, another set. Identity property. So identity property means that it's going to equal itself. Something that equals itself. The identity property allows a number to be added or multiplied, this is a typo, without changing the number. The identity property only applies to, you guessed it, addition and multiplication. Okay, so we're going to prove it. P plus 0 is P. 12 plus 0 is 12. P times 1 is P. 12 times 1 is 12. So if you add 0, or if you multiply by 1, that's the identity property. It's going to equal itself. Identity is who it is. All right, one more property, and then we'll do a little practice, hopefully. The inverse property, you may think inverse, reverse. Inverse usually means the opposite or it's upside down or flipped version. When a number is multiplied or added to its inverse, it returns to its identity. Okay. For addition, a number added to its opposite will result in a 0. And for multiplication, a number multiplied by the inverse or the flipped, and with opposites, we're talking positive and negative, will result in 1. So 12 plus negative 12 makes 0. And 12 times 1/12 makes 1. Okay. This is probably the most tricky one to remember because there's two different operations. Like addition has its own thing we're adding to its opposite and it makes 0, whereas multiplication we're adding the inverse and it makes a 1. So this is one we want to practice the most. All right, we have a little bit of time left, so we're going to do this number 1 for sure. And we are going to apply the property that's given to us in order to equal and create an equivalent expression or equation. So this is the expression that's given to us. It wants us to do the commutative property of addition, meaning we just have to keep it an addition problem. And commutative means move it around. So I'm just going to rearrange 18 plus 7 plus q. Or I could do q plus 7 plus 18. Those both would be correct. This next one is 15 plus b is 0, and we're using the inverse property of addition. They want us to basically fix this letter b. What is going to go there? So it's going to turn into 15 plus negative 15 equals 0. Because when we do inverse property of addition, we're going to add by its opposite. Okay, commutative property of multiplication, same thing as A, but with multiplication, 8 times 3 times 7, or 7 times 3 times 8. The next one is commutative property of addition. So again, same thing as A. I'm just going to rearrange it so it makes the most sense to do 11 plus 9 plus 24, because 11 and 9 are going to make me a nice even 20, okay? But I could have also done 24 plus 11 plus 9. Associative property has to do with grouping, so I'm just going to move my parentheses over. So it's going to be 6 plus the amount, 5 plus 8. And then the last one is the identity property with multiplicative identity property with multiplication. So it's saying 35 times what? And that's going to be times 1, because that will be itself. Okay, we have time for one more. Grady lists 3 different expressions below. Determine which expression is not equivalent to the others. So we have to think about our properties, okay? I can tell that these 2 expressions are equal because of the commutative property, commutative of addition, okay? This one here involves multiplication, and so it cannot be equivalent to the others. And that's it.